Hello, welcome back to my YouTube channel. I'm Kodgata. Today we'll be looking at something fun. It has to do with cryptography, and we'll be looking at how to encode and decode text Caesar cipher. We're also going to be looking at how to encode it and decode it. We'll be decoding the cipher text and encoding the plaintext. So how does it work? What is Caesar cipher? And this is a brief on it. Caesar cipher is a simple substitution cipher named after Julius Caesar, who is believed to have used it to communicate secret messages. It is a type of substitution cipher in which each letter in the plaintext is shifted a certain number of positions up or position down or up the alphabet. For example, with a shift of 3, the letter A would be encrypted as D, B, and so on. The same shift is applied to all the letters in the message. Punctuations, numbers, and spaces are usually left unchanged. We should, however, note that this form of encryption is very basic and is easily breakable, and that's because it only requires 25 possible shifts, and it can easily be deciphered by trying all the possible shifts. So I'll be showing how it works, but I'll be starting from how the shift works. This is a typical traditional Caesar cipher decoder. This is how it looks like. So I will be going on to show you how the shift work. Here I have a named cell, I've named this particular E1 as shift, so we'll be working with that. We should know that it only has 25 possible shifts. So let me drop down. Let me ensure this is formatted as that. The maximum value of this should be 25, and the minimum is 1. So I have to lodge ways of getting the shift, how the shift should work. But first, let's start with the English alphabet. Let me start with sequence. We have 26 alphabets. We have 26 alphabet, and the code of A is 65. In case we don't know, we can just put it here as code of A. Can put it here, but we can just leave it, not to complicate things. We are aware that it is 65. We start from 65. So the character, I will introduce the character function, shell function. So how does the shift work? So for every if we have a shift of 1, that means we will be starting from the second character. We will be starting from the second alphabet, which is B. So if we have a shift of 2, we will be starting from C. That means it will usually be the number of shift plus 1 will be our starting point. So let me demonstrate 2 logical ways of getting it. The first approach is using drop and take function, and then vstack. The number of what's the array here? The array is all these characters. So what's the number of rows I want to drop? Is this shift. then I can have this is this. So you see, because we've dropped one, it keeps, that means we also have to take those ones we are dropping. So I will be introducing vstack here so as to stack whatever we are taking. So we will be taking that same amount of this is our array, that same amount of shift. So you see, since our shift is 3, we'll be starting from D. That's how it works. So this is stop. Okay, we'll be starting from D. You see, that's how it works. Let me show you the other method using sequence function. You know, ideally we say for every shift, the number of shift plus 1 will usually be our starting point. So we can as well use that logic to derive another formula using sequence function. Sequence of the number of we don't have to reference this as rows of this. We already know it is 26 as row of all the characters. You don't have to do that to only complicate things. So 26 rows, and we are starting from this shift plus 1. We'll be having this. You see, we are having some numbers higher than 26. So let's call this X. I could have called it something else, but I don't have anything in mind to call it. So let's call it X. So let's say if X is greater than 26, then X minus 26, else X. Okay, then from here we can do an index of this same index of this. So still the same different logic, same result. So still works. So we are done with that. So let's start with encoding let's start with decoding our cipher text. But mind you, we are not sure of what each shift, because they have varying shift. There is no just a part. We are not aware of the shift each statement has been encoded with. So that means you will be trying possible shift. But let's start with by getting individual letters. There is this formula that we usually use most of the time. Let me start with this. Mid sequence, len of this. Sometimes it can be frustrating to keep typing the same function formula every time. So this kind of formula now, we can make it a custom function. We can make it anything. We can also, there is also another approach which we can also use. Let me name it X. Just for this, let me sample it. We can name it so I've copied that. So I want to do something now. We go to our autocorrect option. let's go to our option. That means we can do Alt FT. Let's go to proofing. So we can have a shortcut for that. Let's see, we have MSL. Once I have type MSL, because it is a mid sequence length, I can just bring this into it. So for it to save our time, so I can bring that in now. It's bringing, you see it's coming up. So we can just replace this sequence length. That has been stored already. So if we open any other workbook it's going to work. Once you type that MSL, it will come up. You can do that for your frequently used formulas. So what we want to do now, this is an encrypted text. This one that means you'll be looking at, you'll be doing a lookup, and our array is going to be the shifted text. It's going to be the shifted text, while our return array is going to be these characters that have not been shifted. So let's our shift be 1. Let's start from 1, so we can always start. So let me say, so let's do a lookup of this. Let's look up. Then what will be our lookup array? It will be this particular one. Then no, that won't be our. We'll be looking at this when we want to encode, but for us to decode, we'll be using this for decryption. Then our return array will be this. However, there are some characters that will not be found, the punctuations, the numbers, and all of. So if the if not found arguments might not work, it will not work here. So I'm going to make use of if NA. But the thing is, I want to return this same argument B12. I want to return it again, but it will result in error. So it's not working. The if any is what I'll use. Because there are certain characters that are not inclusive here. So this is what currently we don't know what if this is making sense to us. This is not making sense. So let's join them and let's make use of text join. Let me just okay. That is doing it. Okay. Let's join. Okay. So that means I'll be trying the shift to see. Okay, it's not working. It's not working. Okay. That means let's check our shift is 4. That means the shift for this is 4. The shift for this is 4. You can try another one. That means I'll be referencing this. We also make everything a formula. We can create a custom function that is going to decrypt and also encrypt as well. But let's just check decrypt this individually. Let me do 2 of that. I want to change it to B3. b3. So let's start from 1 again. Okay, where is our shift? 2. It's currently at 2. Let me go back to 1. Okay, it's not. So let's keep trying. So what's the is 3. Activate secure communication channels. Foxtrot Tango urgent intel incoming. What's that? 3. That's our shift. Where is this? Okay, I'm not sure why it is not typing. It's probably somewhere. Okay, so we've achieved that too. So let's create a function. Should we create a lambda function, a custom function? I think that should be the best approach for doing that. So let's start from let's start creating our this for decryption purpose. So if we can do decryption, the encryption should not take time. Let's start from lambda. And what should be our input? Our input should be the encoded message. Encoded message. Then what again? Shift. The shift. So let's start with let, because we have a lot of argument. At enter. Let's start this here. Let all characters, all chars. Let me just, I don't have to do a lot because we've done most of what we need to do already. Let's copy this. By putting this here, I'm commenting it, so I won't have to type the formula again. So was okay. This our next information should be the shifted characters, or what should we call that? Let me call shift chars. Let me name it something. Shift chars. I'll be using either of those two on, but let me go with this. Let me go with this. Let me go with this one. This looks short. So we'll be replacing this F4 with encoded message. I just copy this. Or can also make use of a notebook too. Can make use of notebook. Wants to do a replace. What are we replacing? F2. Okay, F4 in this case. F4 is what we are replacing. F4 hash is what we are replacing with what? All chars. So I can just replace all. I can copy this. Sometimes when you have a lot to change, it's ideal. Then you can make use of that. So this, what do we have again? This is still commented. So what next do we do? Okay, the made sequence name. So I can make use of the okay, it's not coming up. It's not coming up. Okay, let me just copy this. It's trying to even come up. Okay. So we let's call this characters. These are the letters. I don't know. Letters. The individual letters. I just leave this. Let me give it something short. N. So what's next is to do an XLOOKUP. Okay, I have that already as well. So where do we have that? Seems I've taken it off. Okay, okay, let me just continue. The XLOOKUP of L in all chars. This bit is meant to be the encoded message. Meant to be the encoded message. It's to all chars XLOOKUP L in all chars. Then no, we are looking it should be from the shift chars. I don't know why it's not coming up, but it should still work. In case I've done something wrong somewhere. Shift chars, then return all chars. Then remember, if LA and return encoded message. So what next? So let's call this lookup. So I can join these together. I can join this using text join. For the shift, you could make use of random, but I think you can is quite faster doing it testing from 1 to 25, then trying random of random. I think it's quite faster. So text join for delimiter nothing 90, then bring the lookup. That should be all. But I know this will give me something else. I don't know what I'm doing wrong, but okay. So let me see. What's the issue here? Course name. Should have been like this. So okay, it should work now. But you might be having issues because here I have shift in my lambda. I also have a named cell as shift. Okay, you might be having a conflict there. So let me copy this. Let me go to my name manager. Let me just go. Let me make it instead of the shortcut. Let me make use of this. What? Okay, let's call this decode. Decode Caesar Cipher. What is the spelling of Caesar Cipher? I'm not sure I got it right, but that should not be an issue. Not AE. I have no idea. Okay, so we already have that. So we can test it if it is working. So decrypt Caesar Cipher. What's our encoded message? This. What's our shift? Is this? Is not working. There is something wrong somewhere. Because it's meant to be 4. Wait, is it this same one that I have here? This DF. Okay, that's the second one. And that's 3. Let's try the second one too. There might be issues somewhere. 3. There is. You've not tried our formula before. Okay. Before introducing lambda here. Let's see what this is returning. Okay, let me copy this somewhere else. Let me take this off. Okay, let me come again. Let's try the first one. What's happening? Okay. Let's also have our character here. Okay. Let me see our message. Let's see message is right. Let's see our message is right. Yeah, shift. I can ignore the shift for now. Okay. I can't ignore it. The shift. Let me do it this way. So it's probably giving me what we have here. So what we are having here might actually be an issue of the conflict I was talking about the other time. So what should we do? What should we do? Let me try this again. I want to delete the having this grayed out. I want to delete this particular one. I know I could have named it something else. Let me delete it and try something else. Let me try again. Decrypt. What's the encoded message? And what's the shift? Same thing. Wow. That means the problem is actually still in the formula. It's in the formula. Formula. Okay. So I can see what's going on. Let all shards. Okay. Convention shift. Let's represent our this shift we are having here. Let's make it S. Change everything to S. Shift we are having here. Let's change everything to it. So let's get so let me say S equals to this. So what's okay? Let me name this so I can troubleshoot them individually. So you can see something. Oh, I already okay, that's not a problem. You can see the shift I made, I changed has caused something here. Again. Okay. Message. Let me check all shards. There's your structure. I can't see that. Where is the obstructing let me do place it somewhere else. Let's check what's going on. All shards. Let me try it here. So let me try it here. It's taking time. I did copy the formula the other time. So that is working. All shards is working. Shown again. S shards, let me see. The shift shards. It's working as well. What about the end? Oh, maybe that's exactly where the issue is, because there's nothing like encoded messages here. So let me try this. Message. And that is working. What about lookup? Oh, I've not introduced. Well, I did introduce it. Oh, it shouldn't be the. Should not be. It should be the encoded message. So let me see what's going on. Oh, it should be message, because we don't have anything like an encoded message. It cannot just be the whole message. Should be the L. Should be L, which is the letters. Okay, I think it's working now. So we can make use of this as so let me come again, so as to make it a custom function. Lambda encoded message I don't need to use this encoded message. Then what should we have again? Shift. So let me change something there. Let me change something here. So we have, for every place we have message, I want to change it to encoded message. Just for what again? For every place we have this. I want to replace it with shift. So replace all. Is it working? Oh. Okay, that's short. So hope I have not complicated my problem. Wow, I think that should be all. Let me hold on to this. Oh, there's no equal sign. I think I should stick with what I have before. This particular one. So this should be encoded. No, we don't even need this here. We don't need it here. So let me see where we are going to need it. So shift. I'm gonna call this shift. Shift. So what's going on? Let me see, what do I have to change? Okay, encoded message. So let's try this once again. Formula. I did it wrong. And I don't just press off to. Yes, I want to. So can I try again? So decrypt size shift is this. Wow, it's working now. We don't know. Okay, so let me use shift for this for now, since I don't know what it is. I have to try different one to know what this is returning. So that means this third one is what? Is 5. Shift is 5. So I can just make it 5. So I can do that for these two. And this is what? This is 7. This is 7. Thank you. I think I'm not sure we'll be doing how to do the encoding here, because this video is already long enough, but it's the same scenario. We just be having little changes. So thank you for watching. Thank you.